We are talking about limits. Today we're going to do with two things with limits. We're going to look at them graphically and numerically or tabularly. Okay. This first one, given this table, what do you think f of 1 is? So they gave you some different numbers here. They said, hey, your x values 0.75, 0.9, 0.99, 0.999, or 1.25, 1.1, and so on. You're getting closer and closer to 1. Show me with your fingers, what do you think this missing number right here is going to be? What do you think it's going to be? We're getting a whole lot of 3s. How confident are you that this mystery number is the number 3? How confident? Out of 100%. What percent are you confident? 75? 90? Yeah, I would agree in that. Like, to me, as I look at that, there's like a 98% chance that it's there. They might have done some crazy looking graph, but for the most part, you're pretty confident that it's going that way. Okay? I would say that this is silly, but if you could say with like above 80% confidence, it's probably that number. That's what we're saying there. It's kind of weird, but that's the idea. Okay? What do you think, given this graph? So we just looked at a table. Given this graph, what do you think f of 2 is? So f of 2. So that mystery spot on the graph behind that line. What do you think it is? Show me with your fingers. What do you think? Seeing some zeros, some negative ones, some people with some weird symbols. Okay, if you're saying 0, I would say 0 is the majority. What percent do you think that it's 0?
45.
45, 50. I would agree with that. And if you had to base everything you know on 45%, do you think that's a good idea? No. We don't know what's happening underneath here. A lot of you are saying it's 0 because you are hoping that the graph does this guy. Whee. You ever seen a graph like that? Me neither. That's kind of a weird graph. Okay, so I'm going to guess that that's not true. In fact, we don't know what's happening below there. There's a couple different things that could happen. Maybe it was that first graph. Maybe it looked like this. That's a weird line, but yeah, maybe it looked like that. Maybe it did the other thing where this was an open circle and that was a closed circle. Or maybe this was an open circle, that was an open circle, and the closed circle's down there at -3. We don't necessarily know. Where this last one, we could make a pretty good guess as to what's happening here. This one we don't know because as we approach it from the right side and the left side, we're not approaching the same number. So this one is a big old, I don't know. I wish I knew, but I don't. Again, we're doing limits here. We're going to do this. This will be a 3-day lesson by the time we get done. Each day we'll talk about something a little bit differently. But again, we're going to explore everything in 4 different ways. Today we're going to look at stuff numerically and graphically. We already did that a little bit in Bell work, but that's going to be kind of the thing we'll look at tomorrow. And the next day we'll do the next 2. Okay, so let's talk about limits. Okay, use the table and the graph of f of x to determine the limit as x approaches 2. That's very similar to what we just did. Okay, the easiest way to see it is looking at that table. I got some numbers here. We got 1, 1.6, 1.9, 1.999. Man, imagine that number said 2. And then on this side, we're going up this direction. We got 3, 2.8, 2.1, 2.01, 2.001, and we're getting closer and closer to 2. Based off of that table, what number do you think is written right there that is missing? What number do you think is going to go there? 7. We confident in that?
Yeah.
I agree. I think that missing number is 7. All right. Looking at this graph, it's a little bit different when we're looking at a graph. Okay. We don't particularly care what happens at 2. So think about bell work. We don't care what happens at 2. When we are talking about limits, it's all about what's happening around 2, not at 2. Okay, so imagine you've got a guy right here that is walking on this line. He is going to walk this direction. All right, and then you've got another guy on this side of the line. He's going to walk this direction. If those 2 guys are walking on that line and they're walking both towards the number 2, are they ever going to meet? Don't worry about the line being covered. Do you think that they're going to be able to reach and shake hands? Yeah. If that happens, if they are approaching the same thing from both sides, then the limit's going to exist. It's going to have a limit. At what y value do you think they're going to meet each other? 7. They're going to meet like right there at 7. So if that's true, we're going to say from the table and the graph, it's easy to determine the limit. The limit as x approaches 2 of this function is 7. Again, here's how we say that. The limit as x approaches 2 of f of x equals 7. Just being able to say it. I hate when kids can't. The limit with the little x and the arrow and the number. Just be able to say it. Be a calc student. Limit as x approaches 2 of f of x is 7. Kind of makes sense so far? Down here we get into some pretty drawn out description of what that is. But a function has a limit if the function approaches or equals the value as we approach c. Okay, so we approached or equaled the value of 7 as we got closer and closer to 2. Okay, so as the x gets closer and closer to 2, the function gets closer and closer to 7. That's what we just described. Okay, that's written in a lot of different ways and get some fancy ways, but that's what we just did. First thing we're going to do today is look at this thing graphically. In order to have a limit, the function must approach the same value from the left and the right-hand side of c. That's what we're looking for. All right, so let's look at example 1, the example over here in the corner. We are first going to go ahead and graph x squared minus 2. Show me with your arms, what does x squared look like? It's a parabola. Point, which way is that minus 2 going to take my graph? Minus 2 is tagged on the end, so it's going to take me down 2. So I'm going to go down to 2 right here. I'm going to make a parabola. What's our cheat pattern for a parabola? 1, 3, 5. Up 1 over 1. Up 3, 1, 2, 3 over 1. Up 5, 1, 2, 3, 4, 5 over 1. Parabola. Parabola. Based off of that graph, we're going to answer some limit questions. Now, this is the easiest version of this concept. For letter A, it asks us to find the limit as x approaches 1 of my function. Well, this is a graph of f of x. So I want to know the limit as x approaches 1. 1 is right here. If I had a guy walking on this side of the line going this way and a guy going on this side of the line going towards each other, are they going to meet each other? Show me with your fingers, what do you think the limit is going to be? They're going to meet right here at -1, right? That's my y value. My y value is -1. Everybody agree with me on that? It is -1. Ow. Whatever. Just redraw it. All right, cool. So the limit as x approaches 1 is equal to -1. Done. And we could have done that a lot easier. They gave me an equation. They're not going to do this very much, but they gave me an equation. All I really had to do was take 1 and plug it into that equation. 1 squared is 1. Minus 2. Oh, yeah, it's -1, just like we said. Okay, we could plug in as well. Limit as x approaches -2. Here's -2 right here. If we walk on both sides of that line, we walk towards each other. Are we going to meet? Show me your fingers at what y value are we going to meet? We're going to meet at 2 right there. Okay, we're going to meet at 2 on both sides of that line. Because on the left side and the right side, we're approaching the same number. We're getting closer and closer to 2. Find the limit as x approaches 0. Here's 0 right here. If I walk on the left-hand side and the right-hand side, we can walk together. Are we going to meet? Show me the fingers. What y value are you going to meet at? -2. Done. Good so far? Just keep plugging away here. Okay? So that's pretty easy. That one was simple. Not only could we just look at that graph and they were always going to meet, but we could also just plug in those numbers into that equation. Because if we're equal, then it's going to be the same limit as well. Use the graph to find these limits. The limit as x approaches 0. Here's x approaches 0 right here. Again, we don't really care what happens at 0. I care what happens around 0. So as I walk closer and closer to 0 from both sides, am I going to meet each other? Yeah. What y value are we going to meet? Something ugly, right? Give me a guess as to what that number is. 1.67. 1.67, a lovely choice. A stupid number. I apologize that it's so ugly. But sure, it's 1.67. I think that is correct. We approach the same number, so we're good. They won't make you guess on limits like this. I just did a bad job of making this graph. Let's try another one. The limit as x approaches 2. So the limit as x approaches 2. Here's 2 right here. If I walk on both sides, show me with your fingers, what do you think the limit's going to be? Limit's going to be -2. We're getting closer and closer to -2. Find the limit as x approaches 8. Show me with your fingers, what do you think the limit is as x approaches 8? Yeah, it's something ugly, like 1/2-ish, 0.5, good enough, 0.5, somewhere in this ballpark right there. That looks close to 0.8, and we are approaching the same number from each side. Let's go to the next one. Letter D here. Find the limit as x approaches 4. Okay, so if we're thinking about 4, here is 4 right here. We got one guy on this side walking this line. We got another guy on this side walking closer and closer to 4. Are they going to meet up? No. The guy on the left-hand side here, what number is he getting closer and closer to? 4. What y value is he getting closer and closer to? Infinity. He just keeps going up and up forever and ever because of that arrow. What about the guy on the right side of this line? As he keeps walking, what's he going to get closer and closer to? Infinity as well. They're going to they're both going to infinity, but is infinity really a limit? No, because Buzz said that we can go to infinity and beyond, right? It doesn't stop at infinity. We can keep going forever and ever. So we do not have a limit because we're not being stopped by anything. Okay, we're not approaching the same value. We keep going forever and ever. So we're going to say right here, the limit as x approaches 4 does not exist. DNE, the limit does not exist. It's Mean Girls. Yes. I'm glad that people still get that reference. It came out in 2005. I appreciate that about you too. All right. Find the limit. It does not exist because we're not approaching the same thing. Okay? Limit as x approaches 1. The limit as x approaches 1. Again, I don't care what happens at 1. Okay? If you have to, take your pencil and put it on your paper and cover up 1. If the person walking on the left-hand side and the right side are walking together, are they going to meet up? Are they going to meet each other? The answer is no, they are not. If they do not meet each other, what's the limit going to be? The limit does not exist. It does not exist. As soon as you look at that graph and realize that they are not approaching the same number, the limit does not exist. Okay, so keep that in mind. Yeah. All right, letter F says the limit as x approaches 1, and we get this little guy, a little negative sign on the outside. That is not a mistype. Okay, that is the limit as x approaches 1 with the little negative sign. Anybody have a guess as to what you think that little negative sign means? Inverse. Not an inverse. It'd be to the raise the negative 1, but good thoughts. Where is negative values going to happen on this graph? Over here, right? On the left-hand side? Yeah. That's what this means. The limit as x approaches 1, and that little negative sign right there means the left side of 1. So this is not a two-sided limit anymore. This is a one-sided limit. So again, here's 1. I don't care what happens on the right side of 1 at all now. All I care about is from the left side of 1. So if I were to walk this line just on the left-hand side, what number am I getting closer and closer to? 1. My y value is getting closer and closer to 1. That's where I'm walking. If I did it on the other side, the limit as x approaches 1 with a little plus sign. Okay, I'm walking this way. What number am I getting closer and closer to as I walk just from the right side, the positive side? -1. And that's why E does not exist, because the limit from the left-hand side and the limit from the right-hand side are not the same number. If these were the same, then limit exists. They're not the same, so it's D and E. Kind of makes sense so far? All right, let's keep rolling. On the back side, this just kind of spells it out. I want us to kind of explore beforehand, but that C with the plus sign means just the right-hand side, and the C with the minus sign means just from the left-hand side. Let's try these things. So we got this graph over here. This is obviously a graph of f of x. Our job is to find the limit as x approaches 2. So here's x approaches 2 right here. what do you think, anybody got an answer here? What do you think the limit as x approaches 2 is going to be? Oh, it exists. Max, why do you think it's 0 here? They're going towards each other. We don't care what happens at 2. Cross it out. I don't care what happens at 2. I care what happens on both sides. Yeah, that open circle kind of throws you off for a second. But if they were walking on both sides, would they be meeting each other? Yeah, where would they be meeting each other? At 0, at y value equal to 0. Kind of makes sense on that one. Limit as x approaches 1 with the little plus sign. So here is where 1 is, right here. Evelyn, what do you think the limit as x approaches 1 with that little plus sign is? Yep, it's -2. What does the little plus sign mean? From the right. Did it really matter, though? Nah, it didn't matter. We're just going from the right side, but we're getting closer and closer to -2. Limit as x approaches -3. Limit as x approaches -3. Sarah, what do you think the limit as x approaches -3 is going to be? But there's an open circle there. Yeah, it's still 3. It's 3. Because we don't care about that open circle. Don't let that bother you. Just as you walk on both sides of the line, we get closer and closer to 3. We don't care what happens at 3 or at -3. We care what happens around -3. That's what we're looking for with limits. The last one, the limit as x approaches -1. Show me with your fingers. What do you think the limit is as x approaches -1? Limit as x approaches -1. Everybody go sea turtle on me. It is D, N, E. Here is -1. Those two lines are not approaching the same thing from both sides, so the limit does not exist. Good there? This next part, we get this confused. If I would have started the lesson with this, no one would have missed it. But when we start confusing them with limits, it starts to break our brains a little bit. F of 2, what does that 2 represent? That is our x. We're not approaching anything. It's just x equals 2. So we are going on this graph to where x equals 2, and we're going to state the value. Instead of thinking of two guys walking the line, when we do f of 2, it's like a guy is parachuting in at x equals 2. He is falling right down this line. What's going to happen when he gets to this hole right here? Right through. He's going to keep on going, and then kersplat, he's going to land right there. At what y value are we going to land? -3. So that's what f of 2 is. F of 2 is -3. Do the next two. F of -1. Show me with your fingers. What do you think f of -1 is going to be? F of -1 is going to be -3, because if I jumped in here at -1, I'm going to keep going, boom, until I fall right there, and I'm going to land at -3. Show me with your fingers. What do you think f of -3 is going to be? We're parachuting in. When is he going to land? Never. He's going to fall for eternity. It's kind of dark when you think about it. Try not to think about it too much. But the answer is does not exist there because we don't have a value. There's not a closed circle. Everybody with me through example 3? Just to make sure you're good, try example 4 real quick. Try each of those 6 real quick. See what you get. Let's try it. Limit as x approaches 0. Show me with your fingers. We'll just go through it all together. Limit as x approaches 0. What you get? As you approach 0, that's right here. We go from the left and the right. We're getting closer and closer to 2. Show me with your fingers. What is the limit as x approaches 3 with the little plus sign? 3 with the little plus sign. What you got? 4, because the 3 with the plus sign means just from the right-hand side. So I don't care about what's happening on the left, only the right-hand side. I'm getting closer and closer to 4. Limit as x approaches 3. Limit as x approaches 3. That's a does not exist. Wonderful, because I don't care what happens at 3. I care what happens on both sides. Since I'm not approaching the same number, it doesn't exist. Limit as x approaches 2. That one's easy. Here's 2 right there. I'm getting closer and closer to 2. G of 3. G of 3. I'm parachuting in. I'm landing kersplat at 3. G of -2. G of -2. That's going to be -2 as well. Wonderful. Questions with any of those? They don't get a whole lot more difficult than that so far. We'll do a little bit more later on, but right now that's about as hard as they get. All right, so far we've done this graphically. Now we're going to do it with a table, okay? And we're going to use our calculator to do this. This is not a skill we use quite as much, but it's really important to get a good visual of what's happening. So we're going to use the table on our calculator to find the following limits. We're going to find 5x squared, and we're going to find the limit as x approaches 3. So break out your calculator. Change your mode because you've been in some weird modes here. Make sure you are in radians and a function instead of whatever craziness we've been in. Then let's hit the y equals button. So in the y equals button, we are going to type in our equation. Our equation here is that 5x squared. So for y1, we're going to type in 5x squared. And this thing we really only need to do once, but we're going to go second and then the window button to get me table set. So second table set right here. So second table set. I really don't care about any of the table starts or the tables or anything like that. What I want you to do is go down to independent. Okay, this is basic, the independent variable, my x value. You want to turn that to ask. You only ever need to do that once, but it's pretty helpful later on as well. But we want to change that to ask. Everybody with me to there? Great, now let's go to a table. So hit the second button. And then the graph button up here in the top right-hand corner, that's going to get me to table. So second, and then the table button right there. Mine looks different than yours because yours is probably cleared out. I'll clear mine out to match you. We got this right here. So by turning it to ask, I can now put in any x value that I want. Okay. Our job is to find the limit as x approaches 3. So what do I need to do to find the limit as x approaches 3? What kind of numbers do I need? Around 3. So I need numbers less than 3, numbers bigger than 3. What's a number less than 3? 2. Great. Plug in 2. I get 20. But I need to be closer than just 2. So we could do like 2.8. That's closer. We can get closer than that. We could go like 2.99. And then we could go 2.999. And we could keep going. 2.9999. Does it look like we're starting to converge on a number? Like we're getting closer and closer to the same number? Good. That's good. If you got to that spot, we're probably good. 2.999. You could get crazy with the decimals. That's the left-hand side. That's the numbers less than 2. I also want to look at the numbers bigger than 2. So what's a number just a little bit bigger than 2? Or bigger, a little bit bigger than 3, sorry. 3.00, 3 O's and a 1. Okay? And 3.001. And then a little bit bigger than that, 3.01. And a little bigger than that, 3.1. And we could be like 5. Doesn't matter. There's my table. The whole key there is to see, as I approach this thing from the left-hand side and the right-hand side, am I approaching the same number? Could you say that you're approaching the same number here? What number do you think I'm getting closer and closer to from both the left and the right-hand side? 45. My answer is 45. In fact, we could have done that easier. We could have just plugged in the number 3. Oh, yeah. If I plug in 3, I get 45. That's it. I didn't really have to do all the rest of the work, but we did, and it was fine. Everybody with me to this point? That's not too bad. I'm going to go ahead and hit delete on this stuff just to clear it out so the next time it doesn't look so crazy. You don't have to do it. You can always just write on top of it, but I just like to clean out my table. There's our first one. Let's try the second one. My second one, we are graphing this guy, x squared minus 4 over x minus 2. So I'm going to go to y1. I like typing it in as a fraction. Part of being good on this AP exam is being good with your calculator. About a third of the AP exam is on your calculator. So you want to make sure you can use all the buttons that I'm pushing. Because if I'm using them, it's the best way to do it. Alpha, F1. I'm going to use the fraction button just to make everything nice and clean. On top, I'm typing in x squared minus 4. On bottom, I'm typing in x minus 2. Let's go to second table again. I'm going to that table. We are trying to find the limit as x approaches 2. So what's the easiest way to find that limit? Just plug in 2. We don't have to do all the rest of that stuff. Just take 2, plug it in. Oh, no. I got an error. Why did I get an error for this specific equation when I plugged in 2? There's a hole. There's 0 on bottom and 0 on top here, right? 0 on just on bottom, that would be a vertical asymptote. But 0 on top and bottom, that's a hole. That's why I'm getting an error here. So, all right. That doesn't mean the limit doesn't exist because I don't care what happens at 2. I care what happens around 2. So we're still doing the same process. I'm going to plug in numbers. All right, plugging in 2 didn't work. But what happens if I plug in 1.9 and 1.99 and 1.39? We get that. Does it look like we're converging on a number? Oh no, it's a big scary fraction. You can handle those. It's not that crazy. Plug in a number bigger than 2, so like 2.001, 2.01, 2.1, or 2, yeah, that's fine, 2.1. What number am I getting closer and closer to from below and above? 4. 3,999 divided by 1,000 is 3.9999. Okay, my answer is 4. We found the limits by looking above and below it. We couldn't just plug in 2, because if we just plugged in 2, it's DNE because there's a hole. How good there would be. Let's look at C. One thing you're going to hear me talk about all the time is calculus and absolute values do not mix. Okay, they are not a good comparison with each other. Some funky things happen with absolute values. The easiest way to solve calculus problems that contain absolute values is for you to understand the graph. If you know what the graph looks like, you're going to be a lot better off than anything else. So if you understand the graph of this, it'll be better. This is one you have to memorize. Okay, this is a memorization fact that you should know. The absolute value of x minus 5 all over x minus 5. Let's go to y equals. Actually, I'm going to clear out my table real quick, so next time I come back here, it doesn't look weird. All right, so y equals. I'm going to clear out that. I'm going to go alpha f1. I'm going to pick my fraction bar. I need to do absolute value. There's a lot of different ways of doing that. My favorite way is going alpha f2. Alpha f2, that first column right there is absolute value. That's the one I want. We are doing the absolute value on top of x minus 5. And on bottom, we are doing x minus 5 as well. We type that in. We hit second table. What would be the best number to plug in if we're trying to find the limit as x approaches 5? Let's see if we can just plug in 5. Oh, no, we can't. Okay, we tried. It didn't work. So now I need to plug in numbers below and above it. What's a number below 5? 4.9, 4.99, 4.999. I get -1. Is that the answer to my question? No, we don't know that's the answer or not yet. Right now, that's one side. We have to find a limit from both sides. So then I need a number bigger than 5. So 5.001. 5.01. 5.1. 45. It doesn't matter what I plug in. I'm always going to get 1. What is the limit as x approaches 5 here? Show me with your fingers. What is the limit as x approaches 5? Are you approaching the same number from both sides? Then the limit does not exist. It doesn't exist here. And again, the whole reason for that is because those numbers are not approaching the same value from each side. Look at the graph because, again, this is something you want to see. Let's hit zoom 6 just to understand what this picture looks like. It's a weird looking picture, but it's a straight line and then another straight line. Okay, your calculator doesn't do a great job of showing that to you, but let me show you what's happening here. What's happening here is I am getting a line that goes like this, and then at 5, there is an open circle right there. And right there, there's an open circle right there because that is indeterminate at that spot. If you plug in 5 on top and bottom, you get 0 over 0. Why do you think that line has been shifted over here to where x is equal to 5? Why is it shifted over? Because it's x minus 5. If it just said absolute value of x over the absolute value of x, you'd get the same picture, but the break would happen right here at 0. Okay, that is a picture you need to understand. We will do it a lot more here in the next couple days. Questions with limits?